Welcome, Cybersecurity. This is 233 Server Attacks. Let's begin. Our goals in this lesson are to analyze the packets related to broadcasting, TCP handshakes, and HTTP requests and responses, and see how those packets are involved in the attack. So we're doing Wireshark again. We're doing some analysis of traffic and it's going to be some neat stuff here. So let's get started. First thing to understand, launch your security lab if you haven't, because that takes some time. So we're securing e-commerce site, right? That's the lab. That's the cyber case for this unit. We provide online resources. A user visits the website. There's the front end of the website, like what they see. Sometimes we call it front end. And then there's back end, which is all like the behind the scene processes someone doesn't see. So like you see the front end of the store, the website, and then the regular customer doesn't see the back end. So databases, a lot of like the servers are a lot of back end stuff, right? But that stuff people don't typically see, but they're common targets for attacks because that's where they have real information. So maybe some hackers might try to figure out how to access it when they're not really supposed to. So we got to protect against those attacks on the back end servers and secure sensitive information. We're going to analyze packet data. So the thing with Wireshark, you're seeing all the traffic going around. You can look at that traffic and go, hey, someone's trying to do something wrong. Like if they're trying to access a certain server or access different type, there's traffic to certain locations that there shouldn't be from the outside. You might recognize problems and know where to fix your issues. Data we could put, okay, so we're going to be using data that we're not going to create, that was previously captured. And Wireshark saves data files in something called a PCAP file, so a Wireshark file. All right, so I launched this from the taskbar. We're going to do Wireshark and go to open. Oh, so we want to go to start Wireshark. Okay, so we go boom. And then we're going to go to file open and open packet capture A233. Okay, 233 is our section. Okay, so we're going to file and go to open. And then go to the desktop. And you can go to, is it connections? Oh, what is it called? Packet capture. So go into, didn't see that. Go into activities on desktop A233 and packet capture. Just double click. Oh, wait, am I supposed to double click? Yeah. All right, so what you're going to see, you'll notice the values in the time column become corrupted after 54 seconds of data. This may be due to various problems, including a bug in Wireshark. Okay, so there's a bunch of stuff going on in here. Oh, man. Sometimes I can't see the scroll bar if I do a full screen. So I got to full screen, like it gets, okay, there we go. So you might see the time. They said, hey, like after, there's a lot of traffic, right? And then one thing they said is the time data right now. So it starts at 0 because that's when you hit play. And they said after about 54 seconds, it gets weird. So I'm at 49 seconds right now. And then all of a sudden it jumps to like negative time. They said, just ignore that. I'm not going to worry about it right now. Yeah, but there's a lot of stuff going on in here. Oh, and it might be overwhelming. Don't get overwhelmed. But as you remember from last time, this is where all the packets are. This is details of the packets. And this is the actual like hash data, like the bits, like the ones and zeros. This is what the raw data of what it actually looks like. But this is like this data down here kind of translated to English. And this is just each packet. And every time you click on a new packet, you see different information. All right. Packet 1 is selected. In packet details, you'll see the detailed. Yeah, so if you select packet 1. Okay. How many packets are in the PCAP file we just loaded? Let's see. So we have number of packets here. We haven't filtered anything. We start on packet 1. If you want to see how many packets, I can just scroll. You can just scroll down to the bottom. Oh, geez, it's taken 765 packets. That's what I see. Yep. What is the duration of the capture from the first to last packet? Well, it kind of bugged off, right? Oh. So the duration of capture. Okay, this is the first packet. And then the last packet, I thought they said the time's bugged out, so how can you tell? So usually that time I could look at things, but oh, you can do the details pane. That's right. And look at the timestamps. Okay. So what we can do is, let's say I click the first packet and look at the details down here in the frame. And it starts at 7, so 17, which is like 5 o'clock, 5 p.m., 5:08 and 18 seconds. Ignore the milliseconds. Now, let's say if I click the last packet, I think if I do this, I can sort by the end. Okay, so that was like 5:08 p.m. And this one's going to be at, oh, the time's bugged out, so it doesn't really help me. I think it's just bugged out like it says. That's kind of annoying. Oh, well, but it could be there. Hopefully that's not important. But you can. For packet 1, what is the MAC address? Okay. Oh, good question. So this is reviewing what we could do last time. I'm actually going to make sure it's sorted correctly. And packet number 1, remember how to do MAC address, not in the frame, was in Ethernet right here. And you could look at the MAC address of that sent the packet, the source. So we have our source, which is 20 watt 2 wire 20. That's the name of it. This would be the MAC address right here. And if it's the 3CEA4F20 1A41. All right. Oh yeah, I'm right. Good. That's how you do those 3 things. All right. Good review. So what are the steps how do you request a web page in the background? So like, when you say, oh, I want to go to a website, computers have to like transfer requests and stuff back and forth. There's a lot of back and forth traffic between who's requesting and the website saying, oh, I received your request and here's your data. Oh, thank you for sending it. And it's a lot of back and forth to confirm that things have happened. So using Wireshark, because the malware can occur with any of these steps, you'll look at the packets to validate the content, determine if there are any problems. So we can kind of see this acknowledgement going back and forth. So someone requests a website. So it means you hit enter in your browser, you type it in, hit enter. User host broadcasts a message asking for the address of the requested web server. So it says, hey, where's the web server? And then the router says, oh, it's right. This is the IP address. Then the user host initiates a connection request to the web server. It says, oh, got to connect to the web server. And then the web server responds that they perform a handshake. So they say, oh, yep, hey, let's establish a connection. So you're like, the router's like kind of like the operator. We don't have operators nowadays, but it's like a telephone book, or it's like, hey, where does this website live? And the router goes, oh, it lives here. And then you go, oh, hey, website, I want to connect. And then the user host requests the specific, and then, okay, now we're connected. It's like, hey, can I get this from the website? And then the website says, oh, here you go. Boom. And now you see the website. So it's kind of neat when you break it down. All this is happening, super, super fast. But it's not just, oh, I need the website. Oh, it returns. You have to, hey, you broadcast, where is it? And the router goes, oh, okay, it's right here. And then you go, hey, let's make a connection. And they go, okay. You go, hey, this is actually what I need. You go, oh, here you go. So a few steps in there that would all be documented in Wireshark. So find a host. Recall the MAC address is the permanent identifier or network device that came 6 pairs of hex, right? So MAC addresses are in hexadecimal. If you don't know what that is, oh, we should do like a, okay, I know what I'm doing next. Hexadecimal. So the idea is that we have, I don't know if maybe you haven't done any binary or stuff like that before. But instead of like our numbering system is usually, our number system is usually like 0 through 9, right? That's what you're used to. Well, the idea is that you can have, you don't have to have that. You can have like a base 2 numbering system. So numbers 0 through 9. We call that base 10. But we have other numbering systems. What if you only use ones and zeros? You might have heard of systems like this, and we can call this binary, or it's sometimes base 2. Okay. So yeah, what if we count numbers? And it's weird. Like, you know how counting numbers works normally. Like, I can go 1, okay, start 0, 1, 2, 3, 4, and so on. Well, in binary, the 0 would be 0, 1 would still be 1, but 2 would actually be 1, 0. Because you only have 2 digits to work with. And then 3 would actually be 1, 1. And 4 would be 1, 0, 0. So these are the same numbers. This is base 10. This is base 2 or binary. Now, so yeah, it starts looking weird, especially we're using the same digits. Hexadecimal is base 16. So we're using 16 numbers. And the way we do this is 0 through 9 plus A, B, C, D, E, F. So the way it would look is 0 through 9. If I did this, and this is going to be hex here. 0 through 9 looks like 9. But when you get to number 10 here, we actually go to A. And 11 would be B. And 12 would be C. 13 is D. 14 is E. 15 is F. And when you get to 16, F's the last one. In binary, it'd actually be 1, 0. Kind of like you get to, you move the digit over, right? So that 16 in base 10, normal math, decimal math, and 10, I wouldn't call it 10, I'd call it 1, 0, in hexadecimal are the same number. We do hex. Why do we do hex? Why is it base 16? The way numbers kind of work with a lot of our data is a bunch of ones and zeros, so it's multiples of 2. So typically, a lot of times we're increasing our numbers on multiples of 2. So 2 times 2 times 2, like 2 to the 4th power is 16. And that's just kind of the typical way to organize information like this. It's like, I'm going to dig that up. I'm going to put that as a note. That'd be something to look at more. Why? Why is it base 16? Why not base 8? Why not base 32? Good questions I'm having in my head that I don't have answers to. But that's where the 16 comes from. Why is it not 15? The first 3 pairs are called, okay, so when we're in a MAC address, the first 3 pairs, you got 6 pairs, are called the organization's unique identifier. All right, so like when you make a device, anyone builds a device that's supposed to be on the internet, it needs a MAC address, or could be networked. Like just the card, not your computer, just your network card. You could have like a wireless network card and then like a hardwired network card. You could have 2 of these on your computer. So every time you have one of these, the first 6 is like whoever's making it. So maybe like Linksys makes it, or Cisco makes a router. All sorts of companies that, or what like those, the first part is related to that company that owns the chunk of things. And who's controlling this? Whatever big organization. There's a lot of things are just like, these organizations just control the standards of the internet. And as long as we all follow by these rules, then things function. If people didn't, then we'd have chaos. The device is typically a network interface card. Okay, Nick. Network interface card. Your Wi-Fi card or whatever. Sometimes they'll represent it with the manufacturer's name, like this, in place of the first 3 pairs of digits. Sure. So in the part of the lab, you're going to check whether a packet indicates a valid or invalid OUI. Oh, because, maybe the first part is something that doesn't exist. Like if they say that like certain patterns belong to certain companies, so you can look those up. Malicious users often hide, disguise the identity of the devices, creating a fraudulent ID and throwing criminal investigators off track. Okay, that's cool. I'm going to erase all this stuff. So let's select go to packet or type Control Z. I'm not doing that. Go, and then we're going to go to packet. Oh, this is, I think it's like doing a search and then type 546. Okay. Then do go and go to packet, Control G. I can go 546. Can I type? Oh, that's kind of annoying. Oh, there we go. So, okay, we went to 546. Cool. All right. So we're going to this packet. Now, what am I going to do there? Packet will display. What is the source MAC address of this? The source MAC address, and we already pulled this open. The source is going to be right here. Intel Core 1C. Okay, so it's this address 022 FA1CEBE6. So that's what I would write in. I think that's when we're starting to dock. Oh, we're not even there yet. Okay. And yeah, what do you think the head data in the packets pane is referred to as a hex dump? Okay, my thought is that's a random question, but hex dump because it's in hexadecimal. This is called hex dump down here because everything's in hexadecimal. Okay. it is all hex. Yeah. Now that you'll research an authoritative source that contains a legitimate. Okay, so I have to look up a source that has legit OUIs. You'll attempt to on your local computer open. Oh, that's kind of annoying. Who just showed up? If you just showed up late, can you type in chat so I mark you here? They were a late person. On your local computer. Oh, we have to open this, but you might not be able to open this on Chrome. I bet there's another way to do this. Okay, the file is a copy of the registered authority document. Let me see if this actually, okay. So I kind of right-clicked it and opened it a new tab. And you can probably open this if you're on a Chromebook that way. Okay, thanks, Brandon. Oh, cool. So here's the organization. Like, who controls all this? IEEE, Institute of Electrical and Electronic Engineers. They have the authority to control the MAC addresses. I mean, and where did this organization come from? There's the question too. I'm going to add this to my life questions. Look up in a video. I'll remember that, sure. They're the registration authority that verifies user requests for MAC addresses. I think they do other stuff too. I thought web addresses, and I think it's through them still. So let's find the manufacturer of that computer sent packets. So what I can do is take this MAC address, because that's the first three, right? And I'm going to search for it in this. Now, I'm going to do it as like that. Get rid of the. So there we go. This represents Intel. Okay, Intel makes computer parts, right? Their location, wherever this is. I don't know where MY is. Okay, and Intel has tons of these. Yeah, Intel's a big company, so companies you might not have enough with just one because you keep making stuff, so you have access to a bunch of stuff. All right, so it looks like that is a legitimate one. It is Intel. Which manufacturer created this network? Intel Corporate. This is what I found. Yep. When MAC addresses are found associated with legit, it indicates the address is valid. Okay, so, okay, probably legit. If you didn't find one that was legit, it's probably not, that can be an indicator. Like if you found a MAC address in there for a company that didn't exist, probably not going to work. Although, wouldn't people, if you're a hacker, wouldn't you make one that was? Wouldn't you try to pretend you're a legit company? I don't know. All right. Broadcasting is a way for a computer to communicate with all hosts in the network using one message. Okay, it's most often used when a computer needs to find a host, similar to someone standing in a crowd. So it's like You're like, hey, which of you routers has the address for this? Where's the information? You're just shouting, right? Let's go to packet 484 right now. How do I do that again? If you want to, you can just use this scroll to go to 484. You don't need to do there with fancy way. Oh, but depending on how... Oh, it's getting slowed down. I'm just going to scroll with my scroll wheel. 484, here we go. All right. And record the destination MAC address. Okay. 484's destination address. Oh. Notice the destination, it says broadcast with a bunch of F's. Press F to broadcast. And so the all F's is a special MAC address that indicates, hey, we're broadcasting this to everyone to see. Everyone on the network. So, because this is that individual wireless network, right? When a host, one host needs to locate another host in some other network, it sends a broadcast message asking other routers, who has the address I need? The destination is broadcast, and the packet info shows the host to use the query. Who has this? So you can see on there, the host used a query. Oh. Okay, so here's the information. Who has this IP address? Please tell me. And my address is this one. Let's kind of say, hey, who's got that? You want to find the MAC address associated with the IP address. So it's kind of like, so you got the router, and it says, hey, which one of you MAC addresses has this IP address? Tell me. So let's see what happens. That's like what the router has to ask. You'll find the packet that has the response to the broadcast. The packet list pane. Reselect and review the broadcast packet. Man. Okay, the broadcast packet. Which one was that? Okay, it's protocol. That's this one, right? No, this one's... Okay, whoa, this is getting kind of technical, right? This is getting a little crazy. To me, it is. Okay. You can actually see this writing thing. Oh, only when I'm recording. Got it. Next few steps, you'll find, okay, reselect the broadcast packet and apply a display filter text box. Enter the name of the protocol that is used in this broadcast packet. Use all lowercase letters to identify the protocol name. Okay. Apply a display filter. Moving that away. Okay, and the display filter is this thing. All right, so name of the protocol that was used in this broadcast packet. Okay, so the protocol that was used was ARP. Now it said something about capitalization. Use all lowercase letters to identify the... Really? Always lowercase, ARP, even though that's... Okay. Press the enter key or apply. So we can hit enter. Okay, now these are all... Well, what happens if I do uppercase? Like, don't tell me what to do. Nothing. Okay. I think they just want you to be consistent. I don't know if it actually mattered. Okay. But let's say it does, probably. Now it's only displaying the ARP packets, broadcast ones, related to that. Scroll to the top of the packet list, review the info column. Okay. All right, info column. This one. Review the info column to determine which packet responded to who has this one. Please tell this guy. So someone should be telling destination of 254. So this one's broadcasting. Okay, so this one's broadcasting. So who is sending a destination to this guy? Oh, right here. So this guy says, hey, I have that one. 46 and 47. What is the MAC address of the router who has the host? So the MAC address would be right here. 022 FA1CEBE6. So there we go. All right. You might think there's a lot of broadcasting going on here. I look at this like, wow, really? And who has this? Along with all the responses. And it's a lot. Computers, so it's a lot of information to store, right? So why would you want to have to broadcast this every time? Like that seems silly to go, hey, who has this app? Like, wouldn't you want to save that information? Like, it's like not remembering what you just looked up. At some point, you want to write it down. So what eventually routers will do, or what they will do when they've learned who has what, they'll store the IP to MAC address mapping, so you don't always have to query. So you won't see that kind of traffic forever, unless things change, right? Clear the Wireshark filter. Let's click the X right here. Now we're back to normal. All right. Wow. So we did all this. What did we learn so far? We learned how to look at broadcast messages. We kind of learned how to read through some of these, right? How to like, okay, see someone broadcasting and someone responding to that broadcast. All right. Once a host finds a device in the network with a broadcast, it needs to establish a connection and the TCP, transmission control protocol, and begin. You got to establish that thing, right? So you figured out who they were. The second part was like establish that connection. I went back up to that chart. So establish connection, step 2. Okay. And we use transmission control protocol, TCP. So there's different types of protocols of traffic on the internet. Yeah, TCP is one of them, and it's just it's like our communications. I have establishing my and keeping connections between two devices that are sending data back and forth. Being or establishing a TCP connection is called a handshake, and it must occur for two hosts to communicate. So you have to like handshake and acknowledge that you're going to connect to each other. When you visit a website for the first time, your host and web server will perform this handshake. So for the handshake, you extend the analogy is extend your hand. The second person extends it, and now you can communicate. You're hooked up. So let's look up TCP handshake on Wireshark. Okay, so this is our host found where this is by getting the MAC address. TCAP file will show a TCP handshake between the two IP addresses. There's so many packets you need to filter. And we're going to apply this filter. IP adder is this one. So I'm going to copy, or you can just type it in. Oops, no. Paste. Oops. Paste. Nope, it's not going to do it for me. Okay, and then that's Control Shift Alt. Then we're going to apply this to a filter. Enter. So it's basically filtering any packet that is using this IP address, source or destination. Doesn't matter. So now we have only traffic related to that IP address. Document the filter and describe what it does. Okay, so that just did right there. Basically, we're saying only anything related to this IP address, wherever. Okay. This kind of like takes out some of the garbage. Makes it a little bit easier to manage. But there's still a lot of stuff. Still a lot. Did it remove anything? Like barely, probably. Did it even remove anything? I don't even know. Hard to tell. Okay. Looks like it did something. Probably not too many. TCP handshake may not be the first data you see, so do some pattern matching. The packet list pane, scroll to the first packet. Scrolling down for the SYN packet. Okay. Go down to the first packet. Packet list pane. Okay. Scroll down the first packet. Scroll down looking for a SYN packet, the info column, followed by SYN ACK, followed by ACK. Okay. So this didn't seem like it filtered very well. Maybe it does. Oh yeah, you can see there's like big chunk there. Okay, so how do I look for this SYN? I'm not doing it. I'm not just. I can't. I'm not gonna scroll and find a SYN packet in the info column. Oh, okay. I'm looking for SYN. I got a bunch of ACK packets. Oh, okay, so here you go. So what were these packets then? These are acknowledgement packets, but I don't know. Probably not related. So this is the first like SYN and SYN-ACK and then ACK right here. Okay. I'm going to say that's it. They might not be continuous one right after the other, but they'll be close together. Okay. SYN stands for synchronize and ACK is acknowledge. To understand what happens to a TCP handshake, so synchronizing is extending your hand. You acknowledge that that person extended their hand. And then you acknowledge and you extend your hand. And then now the hands are grasped and shaken. That seems so weird. Huh. And who performed this handshake? So it's 192, 68, 164, and 64, 14, 192, 236. So those two, and then the SYN right here, and then the SYN acknowledge and acknowledge. So these two. So I'm guessing the 68164 is like your local, one of the local servers, whatever probably has the website. And then this 6414 192 is maybe an outside person. Okay, how long did that handshake take? Ah, good question. So if it went from here to here, you also have this acknowledgement, right? I don't know whether there's a bunch of acknowledges. Eh. What does it say? Oh, it's probably because then it starts. Oh, after so this is the first acknowledge. Now it's starting to do other stuff. All right. So from this thing to this acknowledge took what? 1944 to 1905. This is in seconds. So it's almost like a tenth of a second. It's like a tenth of a second at that point. 0.1 seconds, I would say. How long did it take? That's how long it took. Oh, man. Okay, we're going to refine this filter. And upcoming, change the filter from IP address to IP source. Okay. So instead of just saying, hey, anyone with the IP address, let's say only do source file. So I'm going to go in here, do src. So with only this address as the source. Okay, so a lot fewer of these things, easier to see. Document and describe what it does. Well, I would say that only IP address in the source of 164. You now see traffic only from one host. It's easier to see the security protocol packet that is sent. For example, the packets are responsible for packet level security. Use this protocol, TLS. Oh, let's just throw a bunch more words at you right now. Welcome to class. Transport layer security used to secure TCP transmissions. Okay. Blah, blah, blah. Select the first packet near the top, TLS 1V. So I think it's this one, 90. And okay. Packet details pane. Expand the secure socket layer entry. Then the layer. Okay. So secure this and then the. Which one? Record layer. Which one? This one? Record TLS v1 record layer entry. What? They're the same. Okay, which one of these? I don't know. Handshake protocol, client hello. Okay, so it'd be this one. Okay, so it looks slightly different. An additional secure handshake occurs. Okay. Secure handshake information, great. Scroll through the data. This handshake is much more involved. Ugh. All right. So scroll through it. The handshake is much more involved. On secured handshake, with only 3 simple packets. You think it'd be harder. So what's going on in here is what data? Okay, it's all this encrypted handshake. Okay. So I guess you can say this TLS thing has more stuff going on, more data. Just a simple handshake. Okay. Cybersecurity. So it changed cybersecurity. I mean, basically with this, we're making a more secure connection. All right. At this point, I'm going to stop this recording. We'll do a second half.